Hey everyone, we'll be starting with coordinate geometry. So basically, coordinate geometry consists of many parts. First, we'll learn the basics of coordinate geometry. Then we'll be going through straight line, circle, parabola, ellipse, and hyperbola. All of these parts will be covered in our high school coordinate geometry. And first, we'll be starting with basics. So let's just dive straight into it. So first, in order to understand coordinate geometry, what we need to understand is how a Cartesian coordinate system or rectangular coordinate system works. Now, what is Cartesian coordinate system? Basically, if you plot two lines, let's say first line that I plotted is y o y dash, the second line that I've plotted is x dash o x. So what happens is, let's say both of these lines are mutually perpendicular. So the plane in which we have divided it into four different regions, which are called as quadrants, in which this is the first quadrant, this is the second, this is the third, and this is the fourth quadrant. Now, one characteristic that we have to learn about the Cartesian system is that whenever we move towards the right, this is called the positive x-axis, and whenever we move toward upwards, it is called the positive y-axis. And the point of intersection of the y o y dash line and x o x dash line is called as the origin. Okay, great. So now what we do is we measure the distances. Let's say I have a point on the Cartesian system. Let's say this is my Cartesian system and I have to give an identity to this point. I have to define this point. How can I do that? The way which I can do this is by measuring its perpendicular distance from the x-axis and measuring its perpendicular distance from the y-axis as well. The perpendicular distance of the point from the y-axis, the modulus of the distance, is called its x-coordinate, and the perpendicular distance from the y-axis, from the x-axis, is called its y-coordinate. Now, one characteristic that we need to learn about quadrants is that if we observe any point in the first quadrant, say here, point A, point B, point C, or any point, they're always towards the right and upwards. So they always have a positive x coordinate and a positive y coordinate. Similarly, if we talk about the second quadrant, we're going in the left direction to find the distance from the x-axis and we're going upwards to find the distance from the y-axis. So in this, the x-coordinate is always going to be negative because we're moving in the negative direction as defined by us earlier, while y-coordinate will be positive. Similarly, in the third quadrant, it will be negative for both x and y, and in the fourth quadrant, it will be positive for the x-coordinate and negative for the y-coordinate. So this is how the rectangular Cartesian system works, okay? Now, moving to the next part, once we have learned that how we define a point in a rectangular coordinate system or the Cartesian system, let's say this is our x-axis, the horizontal line which we defined earlier as x o x dash, that is called as the x-axis, and the vertical line which we defined as y o y dash is called as the y-axis. Okay. Now let's say we have any point. So we can easily write its coordinates, or basically we can write its position. The coordinates are basically its position. So let's say the distance here is A and the distance here is B. So its coordinates can be written as plus A, plus B. Similarly, if I'm measuring the same distance in the second quadrant, A and B, I'll write it as minus A, plus B. In the third quadrant, minus A, minus B. And in the fourth quadrant, I'll write it as plus A, minus B. Alright, that must be clear now. Now moving to the next part, which is translation of a point. Now what happens if a point is being translated? Let's say I move this point in the positive x direction by k units, or let's say I move it by h units. Now what will happen to the point is that it will get converted into another point. Now how do we define the coordinates of this point? Right. So if you look at the way I'm moving, the perpendicular distance from the x-axis is the same as it was before. but the perpendicular distance from the y-axis is changing, which means you can see that the perpendicular distance from y is changing while it is same from the x-axis. So that means that if we are moving in the positive x direction, the x coordinate of the point gets changed. So we can write this x coordinate as x plus h comma k. Why did I add a h? Because we're moving in the positive x direction and the distance from the y-axis has increased by h units, whereas the distance from the y-axis, distance from the x-axis, which is the y coordinate, it remains the same. So that is how the coordinates change for a given specific point when we are translating the point. Let's say I have another point. Now let's say I move this point upward. Let's say k units. And we find new point p dash. Now how can we write the coordinates of the point p dash? Basically, now the distance from the x-axis has changed, right? We have translated upwards in the positive y direction, so the distance from the x-axis has changed, which means the y coordinate has changed, whereas the x coordinate still remains the same. So the point P can be written as x comma y plus k. Why am I adding k? Because I moved in the positive direction. Moved upwards, and upward is defined as the positive direction. Had I moved downwards, k units, the coordinates would have been x comma y minus k. So this part is pretty easy whenever we translate a point. For now, what we'll be studying is we're translating points either in the positive x direction, in the negative x direction, in the positive y direction, or in the negative y direction. We can translate them at any arbitrary direction, which we will be coming to in the later portions of the chapter. Now let's move to a question. The question says, find the number of integral points exactly in the interior of the triangle with the vertices 0, 0, 0, 21 and 21, 0. The first thing that we're going to do is we're going to plot these points, okay? So I've drawn the Cartesian system. 0, 0 is the origin. 0, 21 lies on the y-axis. Why? Because the x-axis is 0. That means x coordinate is 0, which means that the distance from y-axis is 0. So basically it lies on the y-axis. So this point can be called as 0, 21, whereas the point 21, 0 has a distance of 0 from the x-axis as its y coordinate is 0. So it lies on the x-axis and it lies here 21, 0. Now if we join the point 0, 21 and 21, 0, what we obtain is a triangle, right? Let me just trace the sides of the triangle. This is the triangle that we have obtained. Let's label it as A, O, B. Now we have to find the number of integral points in the given triangle. By integral points, what we mean is, let's say there is a point x, y inside the triangle. So x has to belong to integers and y also has to belong to integers. But right now we can't decipher anything, that how can we actually find the point. So what we do is, we extend both of these lines like this, okay? Extend this and we extend this. And now if we try to find this point, this will be 21, 21. How will it be 21, 21? Look. The distance of this and this is gonna remain the same, right? So the y coordinate be called as 21. While the distance of this and this is also gonna remain same. So the x coordinate can be also called as 21 and the y coordinate can be also called as 21. So this coordinate will be 21, 21, alright. So now we have to find the number of integral points inside of this triangle AOB. Now look carefully that how can we do that. In order to do that, what we need to do is to find in the insides of the triangle. Let's say we have a point here 1, 1. We have another point here which is 2, 1. Similarly, we'll have points till 20, 1, and the point 21, 1 will lie exactly on this side because its x coordinate is going to be 21 and the whole line which has been made has all of its x coordinates as 21. So that will not lie inside the square AOBC. So from the point 1, 1 to point 20, 1, we're gonna have 20 points which will be inside the square. Similarly, if we move from 1, 1 to 20, 1, we will again have, if we move from 1, 1 to 1, 20, we will again have 21 points which will be inside of the square AOBC. So 20 points in the y-axis and 20 points in the x-axis. So the total number of points that will be inside the square can be said as 20 multiplied by 20, which is 400. So we have 400 integral points inside the square AOBC. Now what we need to do is we need to find the number of points which are inside the triangle AOB, right? But right now we have found the number of points which are inside the square. So the problem still consists of a few parts. Now what we do is we found that there are 400 points inside the square. If I simply divide it by 2, I'll get 200 points, right? But all the points which are on this line, the line AB, they are not inside of the triangle, instead they lie on the triangle. So we need to deduct those as well from the total of the 400 points that we have obtained earlier. So we need to count the points on the line AB. Now how we do that is, what will be this point? It's clear that this point will be 20, 1. How can it be 20, 1? Right? See, let's say I move one distance down. This is the point, right? I move one distance down. So the y coordinate will be 0, 20. And I move one distance here. So it will be 1, 20. Similarly, the next point will be 2, 19. And in the same fashion, I'll move till 20, 1. So how many points am I exactly obtaining on this line? I'm obtaining 20 integral points on this line. Now what I need to do is I need to subtract these 20 integral points which lie on the line AB from the total of 400 lines I've obtained from the square, which will give me 380 points which lie inside the 380 integral points which lie inside the triangle ACB and the triangle AOB. But the number of points that I'm supposed to find is only for triangle AOB. So now I can simply divide it by 2 and I can get my final answer, which is 190 points. So 190 integral points will lie in triangle AOB. Great. Now I have another problem here, but before solving this problem, we need to understand a few important concepts. So let's just quickly go through them. Let's just understand the concepts by the means of the question. So let's just read the question first. The point 4, 1. So there is a point 4, 1 on the Cartesian system which undergoes the following transformations successively. Reflect about y is equal to x. Now what is y is equal to x, right? First we need to understand that. Let's come to this. But first let's go through the question. So the point is apparently getting reflected by something called as y is equal to x. Then translation through a distance of 2 units along the positive x direction. So what's happening is, once we have obtained the point from the reflection, the point obtained has been translated 2 units in the positive x direction. So what we can do is we can add x plus 2 to the point obtained. Let's say we obtain x comma y from the first transformation. So whatever point we have obtained, we'll just add 2 to the x axis, 2 to the x coordinate of the point, and we'll obtain a new point. Rotating through an angle pi by 4 about the origin in the counterclockwise direction. Now what does this mean, right? So let's just start solving the question and all the concepts will get connected automatically. So let's just write the solution for this question. First of all, what we need to do is we need to plot the original point, which was 4, 1. 4, 1 signifies that its distance from the y-axis, which is the x coordinate, is 4. So basically you can just go about it like this instead of calculating distance each time. But this is 1, 2, 3, 4, 4 and 1. So it's here and its coordinate is 4, 1. Okay. Now what happens is it's getting reflected by the line y is equal to x. So first what we need to understand is that what exactly is y is equal to x, right? So y is equal to x signifies the collection of points in which the x coordinate and y coordinate is same. Let's say this is a point. Okay, 1, 1. Its x coordinate and y coordinate is same. So it satisfies y is equal to x, right? Similarly, this is another point 2, 2, which also satisfies y is equal to x. Now if we keep plotting such points, we'll obtain an infinite number of points which will satisfy the given equation y is equal to x, right? So what we obtain is a straight line which we can call as y is equal to x. Okay, the straight line is termed as y is equal to x. It is a line in which the x coordinates and the y coordinates are equal. Any point you get on this specific line will have the same x coordinate and the same y coordinate, let's say k comma k, and this will be true for all the points on this line. Now what happens is that whenever you take the reflection, what does reflection mean? That if you're on this point, you go about it like this and you measure the same distance again perpendicular to it, right? So this gives you the image of the new point. Now whenever any point, let's say any arbitrary point a comma b is reflected about the line y is equal to x, it always gets reversed. Basically what you obtain is b comma a. May it be for any quadrant and for any point. Okay, so if 4 comma 1, if you want to know how this came exactly, we'll come to this later in another part. But right now what is necessary to understand is that whenever any point is reflected about the line y is equal to x, it just gets its x coordinate and y coordinates get swapped. So the point that we will obtain in the first transformation will be 1 comma 4 after first transformation. Now moving to the second transformation, which says that the new point obtained, which is 1 comma 4, when is translated 2 units in the positive axis. So now what we can simply do is we can add 2 to the x coordinate and we'll get the new point, which will be 3 comma 4. Now for the third part, which says that the new point which you have obtained is 3 comma 4. It is rotated through an angle pi by 4 about the origin in the counterclockwise direction. Let's break this down. So basically we have obtained a point 3 comma 4 after going through 2 successful transformations, right? Let's just plot the point quickly on a graph. Three comma 4 will lie somewhere here, right? So this is our point 3 comma 4. And what happens is, let's say this is the point. Now what exactly we mean by rotation is that this is rotated by 45 degree, or we can say pi by 4 radian, and at the same distance from the origin we obtain a new point. So this is how rotation occurs, right? You take the point and you rotate it like this, given that if this distance, let's say, is 5 units, this distance will also remain 5 units. Now how exactly did I obtain the distance 5 units? You can simply use the Pythagoras theorem for that, right? This distance is going to be 3 units and this distance is going to be 4 units. So this distance can be clearly stated as 5 units. Also what we can say is that this angle, what will this angle be? If this is 4 units and this is 3 units, right? Clearly we can say that this angle is 53 degree, or which you might have studied in physics, or you can just call that, what can you call it? You can call it tan inverse 4 by 3. Right, so this angle is tan inverse 4 by 3 because if you say theta, tan theta will come out to be 4 by 3. So this angle can just be called tan inverse 4 by 3. So the remaining of the angle, which is this angle, right, this can be called as pi by 2 minus tan inverse of 4 by 3, or it can be called as tan inverse 3 by 4. Okay. This is a basic property of inverse trigonometric function. If you really want to know how I write it as tan inverse 3 by 4, what you can do is, you know that this distance is 4 units, right? And this distance is going to be 3 units. So the tan theta of this will be 3 from here and 4 from here. So it will be basically tan theta for the angle, which is in the red color, will be 3 by 4. Okay. Now the whole angle here is pi by 4, right? So what we need to do is we need to find this angle again. We're using basic trigonometry here. Now this angle, if this angle is tan inverse 3 by 4, this angle will be pi by 4 minus tan inverse 3 by 4. Right. Yeah. So now what you can do is, you know the distance, right? You know the distance is 5 units. like I told you, the distance from the origin always remains same in the case of rotation. What you can do is you can simply take the cos of this angle, which will give you this length, right? If you take the sine of this angle, it will give you this length. 5 into sine pi by 4 minus tan inverse 3 by 4 is going to give you this distance, and this distance is basically the x coordinate, but we have to add a negative sign to this. Why? Because we are moving in the negative x direction. Similarly, if you do 5 cos inverse pi by 4 minus tan inverse 3 by 4, what you will obtain is the x coordinate, the y coordinate, which will be this distance, or you can call it as this distance. So this will be the coordinates of the final point obtained after 3 successful transformations. The rotation part, if anybody faces problem, can be discussed again. You just have to comment. Okay. This part is a bit tricky, and understanding it on the first day of learning coordinate geometry may be hard. If you want, I can make you go through more questions. You can just comment. Okay, this will be it for the video. Videos will be rolling in a regular manner, and the whole coordinate geometry will be covered soon. Thank you.